Welcome everyone to today's webinar. Thank you for taking time out of your busy day to spend time with us. We are super excited to share with you the work of these amazing educators from Duke University, Pratt Institute, and Minneapolis College of Art and Design. It's really all about jobs and the economy. Schools will attract students to meet the demand of industry to make greener products, and manufacturers and product development organizations will recruit and hire students who can execute on this new way of working. And that's what using Sustainable Minds, Eco-Concept, and LCA software is all about. Its use in education is to teach people to think differently so that they can act differently. So a little bit about Sustainable Minds. I'm Terry Swack. I'm the CEO and founder of Sustainable Minds. I founded the company in 2007, and our mission has never changed. Our mission is to operationalize environmental performance in mainstream manufacturing and product development to drive revenue and growth through greener product innovation and healthier product innovation. We launched this tool that you're going to be hearing about today in 2009. It's the very first streamlined LCA software tool delivered in the cloud specifically for product development organizations to teach lifecycle thinking and to integrate using LCA in product development to ultimately design greener products from the start. The team that I put together to create this first tool consisted of LCA experts with expertise in material science, customer experience, and web-based product design. That's actually my background, and information design, and a great development team. Over the years, as greener products became more of a thing, let's say, and more people started saying, you know, we should really be designing greener products and improving the environmental performance of products or reducing the impacts on products, we saw kind of a natural adoption of this tool in higher education and not just industry. And over the years that this tool has been available in the marketplace, we've seen it used all around the world, surprisingly, and specifically in over 500 colleges and universities of every discipline, business schools, graduate and undergraduate, engineering schools, chemical, environmental, civil, mechanical, and design programs, which you'll be hearing from two of our design program educators today. From that foundation of creating that first streamlined LCA tool and becoming really experts at simplifying LCA to make the results understandable to regular people, we began to focus on the building construction industry in 2012, 2013, becoming what's called an ISO 14025 EPD program operator. We developed the technical standards for how the rules for how LCAs need to be done to publish public disclosures that are called environmental product declarations. We deliver LCA services, and we've created a platform called the Transparency Catalog for the building and construction industry for people to be able to find every manufacturer investing in environmental product declarations so that the building and construction industry folks can actually find higher performing products as disclosed through their LCAs and EPDs. And our perspective has also never changed. We help operationalize that discipline and that knowledge into those organizations so that they're creating this content to differentiate their brand and to integrate it into product marketing to literally create a greener brand. So now you know where we started, you know where we are now, and let me bring us to today's content. I'm going to start by telling you a little bit about the concept of why combine eco-design and LCA into a single tool. So I'll give you the context for the tool, and then you'll hear from Holly, Carolyn, and Gary about how they're using it in their own courses and curriculum. So, the premise is that there isn't one person who makes decisions about products in an organization. There's lots of people who make decisions about products. And if the commitment for the organization is to make higher performing or less impactful or greener, they all mean the same thing. Green is just code for those other two things I said. Then everybody has to be on the same page about how to think about the product life cycle. And we, again, just to visualize this, to make a credibly greener product, you can't just measure the life cycle. You can't just do the LCA part. You've got to get people to think differently about how to design and make products. And then you use the LCA part to measure the results of those changes or those strategies in the way that the products get made or in the life cycle of the products. It's really the eco-design or the life cycle thinking, so it's the same, means the same thing, that drives the innovation. Measuring, doing LCA is what makes sure that you're making improvements and not unintended consequences of making changes and having it backfire in other places. So, and today especially, I mean, we introduced this in 2009. Green still wasn't really that important, but today it really is top of mind, and it has become an important criteria across all of product development, just like traditional criteria like functional performance, cost, aesthetics, safety. And people really are realizing that creating lower impact, higher performing products is an innovation driver that should actually lower cost to make it and increase revenues. And you're uniquely going to hear from Gary today about, in his course, he has coupled cost with environmental performance. And the reason to evaluate the environmental performance of products in early stage design is because 75% of the manufacturing costs are committed in early stage design. Once you get into detailed design, the criteria or the attributes that lock in the environmental performance are literally locked in. So material choices, energy requirements, recyclability, lifetime of the product. And so once you get into detailed design, it's very expensive to make changes. So the ability to rapidly create concepts and assess and compare how different decisions change the environmental impact of the product is a really valuable design tool. So, as I said earlier, everybody has to think the same way about the product life cycle. Traditionally, product life cycle was considered cradle to gate, but whole product life cycle is from raw material acquisition through material manufacture, product manufacture. You've got transportation and distribution between each stage, the use phase, and then end of life. And so to really explore how things can be improved, you have to look at what's happening in each life cycle stage. And this is where the eco-design strategy, life cycle thinking comes into play, where there are strategies that can be applied in each of those life cycle stages to investigate how performance improvements or impact reductions can be made in each of those stages, whether you're comparing a new concept to an existing product or you're comparing a concept to another concept. This is the geekiest slide in the whole presentation. What we've done in our tool to make it accessible to non-LCA experts is we've simplified the science or the chemical engineering part of life cycle assessment by taking all of the inputs that go into a product system, breaking it down into their chemical components, running those through a life cycle assessment methodology lens, where each of these chemicals gets attributed to one or more impact categories. So these are called midpoint categories, which all roll up into endpoint categories that show how those chemicals are contributing impacts to human health, human health, and the natural environment or the built environment. This is a quotable quote. People have picked up on this for years, that I've said this, that there is no such thing as a green product. Green is a relative value. It can only be greener than something else. So at the core of the application is this comparison tab, where as people create concepts, it automatically compares the new concept to the reference concept. And so at the end of the day, what we've built is the capability to do eco-concept modeling with real-time LCA-based results. So with that introduction, I'm going to turn it over to Holly. And Holly, take it away and show us and tell us about how you're using our software in your curriculum.
Great, thank you, Terry. I'm going to talk about how we actually use Sustainable Minds software to support design decisions. So you can use it at different stages in the design process, but in this case, I'm going to show you how we're using it specifically to drive innovation and design ideas. Let me back up. I am by trade a graphic designer, but I've also been an instructor. So for 30 years, I've been a practicing graphic designer. I have my own design firm currently called This Is Folly in Minneapolis. Formerly used to work at Target as a creative director. And I am our Masters in Master of Arts program co-founder. And we founded this program because we believed that we weren't seeing that designers were getting educated at the time in design for sustainability, and we realized that they have the key to unlock the promise of sustainability and the fact that they need to redesign absolutely everything to be sustainable. So I teach at the Minneapolis College of Art and Design in Minneapolis. We've got a whole variety of undergrad programs, 14 bachelorettes of students from all over. You have your kind of standard MFA program. And then we've added these 3 online masters. Ours was the first online master, and that is our Masters of Arts in Sustainable Design. So we founded the program originally in 2004, was a certificate program and offered a variety of classes, and then became a full-fledged MA in 2013. It is 100% online. It was built to be online. It was built for creative working professionals. We were able to build this program from the ground up. We didn't have to bolt it onto any existing program. And we built it so that it is discipline agnostic. So you could be an architect, you could be a fashion designer, you could be a graphic designer, package designer, even some kind of entrepreneur. We even had an aquaponics engineer at one time come through our program. It doesn't really matter. We understand that you learned your how to do your basic discipline in your undergrad program and in your career, but you were never taught at the time how to do it sustainably. So we have created this sort of universal approach to design for sustainability that can apply to all of those disciplines. And I think what also makes our program unique is that life cycle thinking is a foundational component of our program. It's throughout everything that we do. This particular course that I'm going to show you examples from is one that I teach called The Practice of Sustainable Design. Students learn how to incorporate design for sustainability in their respective design practices. In our program, or in this course, they learn about the role of designers in society, professional best practices, systems thinking, life cycle thinking, all of the design for sustainability concept strategies, tools, responsible sourcing, issues around material health, standards and certifications, things like ISO standards and green certifications, and how to evaluate those, and use critical thinking, and of course life cycle assessment, as well as many other things. In this particular, they have basically in this course, they have a semester-long project, and so they can incorporate sustainable minds throughout that process as one of their tools. They get to choose their own project. It often leads to their thesis work, so they get to do some deep research and exploration in this course while learning how to weave sustainability concepts into their normal design practice. So they go from beginning to end in this course. And so they use sustainable minds often while exploring life cycle supply chains and materials in the weeks 7 to 12 in the middle of the project. And the outcome of the course is a process book that is a full design presentation that shows all the different steps that they went through. So if someone wanted to know, well, what did you do in this course, or how do you practice design for sustainability, they could actually show all the steps in this final presentation. And so they use sustainable minds in this course to really inform design decisions and to drive innovation. And I'll show you how that works. So in this first example, the project was really, the student wanted to figure out a way to drive innovation in the golf industry, and they were exploring various ways to do that. And then when they got to the part where they needed to do some life cycle exploration to better understand materials, they decided to take something as simple as the golf shaft to just understand the golf club's shaft, to understand the materials better. And so they were comparing stainless steel and carbon fiber and titanium and some other ones, and then kind of narrowed it down to these two. And they found by going from stainless steel to carbon fiber, there was a 94% improvement to the base. So carbon fiber seems to be the answer to which is the least impactful. But the student, the more they really thought about it, started to address this systemic issue that golfers really upgrade their equipment way too frequently for what they get from the industry are these very minuscule perceived performance improvements, and then the amount of energy and money that the industry is putting into these tiny, almost imperceptible performance improvements is ginormous. And so she ended up thinking that that was what she should focus her project, and indeed eventually her thesis on. Yep, skipped ahead. So the key learnings were really reducing the need for replacing golf equipment frequently is just as important as the material that it's made out of. So the student pivoted from a material swap out strategy to an innovation strategy, focusing on issues like design for reduction, design for durability, and design for behavior change. In the end, what the student ended up developing was a innovation and sustainability challenge competition for the golf industry, leveraging their existing behavior of competition, being very competitive, but to get them to work together to explore ideas in the World's Fairway competition to help drive their innovation and break down resistance in the industry. This next student had a much more narrow focus in the beginning, was just wanting to compare, she works for a packaging company, wanted to compare some of their base level packaging. I'm sure this looks familiar, this candy packaging. She was looking at the toppers and the other kind of materials. So she picked out 3 potential materials and started to explore them, and discovered, a 64% improvement by simply going to recycled high density polyethylene, and then also potentially nearly the same if they switch to PET. But really discovered as well that the blow molding is, once you switch away from the original material, then the material impacts are less, and the blow molding actually became the most impactful part of the process. And so in the end, her learnings were, in the short term, to switch to recycled HDPE or PET, but in the long term, really got her thinking about how the company produces materials and looking for overall systemic improvements. So the student also switched from a material swap to an innovation strategy and looked at design for reduction using recycled content, optimization. What they went on to do for this course and again for their thesis was to work on creating a process for her company to better represent what they could do to sustainability for sustainable packaging solutions for their clients, to help really bring the clients on board earlier. And so she created a whole toolkit and a database for cataloging all of the solutions and a way of approaching the clients. And so she was helping align the entire company internally, and then externally attempting to figure out how to get clients to be willing to do more sustainable packaging. In this last example, the student was interested, she was an artist and an art rep, and she was interested in helping make more sustainable paint materials. And so she started by looking at acrylic paint, your basic commercial cotton canvas, in overseas production. So if you just went to your normal, Dick Blick or whatever art store and bought stuff, what the impacts would be. And so she explored all of that to create a baseline. And she explored options like what happens if she went from a commercial cotton canvas to a commercial wood substrate, but still overseas, saw 88% improvement. What if she actually she got interested in foraging paint and actually using plant materials locally sourced and then still on a commercial substrate. So she really discovered that the substrate was, because it's a lot of the bulk of the product, ends up being a lot of the issue. But then she really tried homemade paints, homemade substrates, and local production, and that really gave her the improvement that she was looking for. So again, if the question is, what are the impacts of the various materials, the hard answer is that the substrates, because they have the most volume, also tended to have the most impact, but locally made, locally sourced biological materials gave the most improvement. So she ended up in the course of her research really diving into the material health aspects of acrylic, and discovered in fact that acrylics are far more impactful in terms of microfibers in the ocean and fugitive fibers than the textiles that we're so frequently hearing about. And this shocking number encouraged her to really find a way to get away from acrylic paint. So she started focusing on design for composting, design for regeneration. And then the results were that she developed a whole bunch of recipes based on old recipes for making paints and pigments and dyes from things that she found within 25 miles of her home. And then developing this innovative idea for a farm-based art hub and business that could actually grow, make, process these materials, offer them to artists, bring artists in, this whole kind of farm to canvas kind of concept with classes and products, and actually would help drive local economies for hobbyists, farmers, artists all together, while making everything regenerative. So our students really use Sustainable Minds to learn more about, to think critically and really evaluate materials and better. And they also much better understand the implications of design decisions. Once you actually see those numbers play out, I think it's something that you can't ever forget, and it really changes how they think about things. And they learn how to integrate LCA, even if they're never the ones to do it. In reality, they learn how to leverage the data and see the opportunities in the data by integrating it into their design process. And they understand that reality may be a lot different than what is assumed. And so they're inspired to pursue more innovative systemic ideas than they might otherwise be, by understanding that the materials only get you so far. And then from our perspective, we also like the fact that the students experience feedback in real time, so that's very helpful for them to shape their decision making, and that they learn that solutions are actually knowable, that we can figure these things out, and that LCA can also be leveraged to teach material health, supply chains, and other sustainability issues in kind of a tangential sort of way. And I think in terms of preparing students for industry, I think, you know, we need more literacy around sustainability and life cycles in all disciplines, even beyond design disciplines. And of course, we always need more data sets, and we need tools to be user-friendly. And I think that, you know, obviously this information gives them the foundation for making decisions in industry. And that I think for industry takeaways would be that I think they need increased awareness that people trained in design for sustainability can bridge that gap between setting goals, because what I see often in companies is that they set goals, but then they can't meet the goals because they can't actually reimagine how they do everything. And that's what creatives are good at. And designers trained in design for sustainability, they can be the ones that innovate and re-envision and bring to life those new products, the new business models, the new systems that we need, if they only get tapped to do that.
Well, thank you, Holly. That presentation was so interesting, and I've never heard this before, farm to canvas. And I love that.
Yep, she's trademarked that.
Excellent. And by the way, attendees, this webinar is being recorded. You will get an email in the next day or two with a link to the recording. You'll be able to request the deck if you would like it. And if you have any questions along the way, feel free to put those into the questions panel on the control panel. We'll try to answer any questions you have at the end of the webinar, but any questions you have that don't get answered, we will absolutely follow up, get those questions answered for you. When you exit the webinar today, there are a few questions. We'd love for you to give us feedback, and also any questions you didn't ask during the webinar, you can leave as you exit, and we can follow up with those as well. So Carolyn, turning things over to you.
Thanks, Terry. Okay, so my name's Carolyn Schaefer. Oops, sorry, got a little jumpy there. My name is Carolyn Schaefer. I'm the Director of Sustainability for Academic Affairs at Pratt Institute, and today I'm going to be sharing how Pratt has been using sustainable minds in the classroom for many, many years at this point. First, a little bit about me. I run something called the Pratt Sustainability Center, which is one of our research centers. I teach in the Graduate Center for Planning and the Environment, and additionally, I coordinate something called PALS, which stands for the Partnership for Academic Leadership and Sustainability, which is a consortium of art and design schools focused on integrating sustainability into the academic experiences of our students at our home institutions. And before coming to Pratt for my master's degree in industrial design many years ago, I also worked as a mechanical engineer, which is what I studied for my undergraduate education. Pratt's main campus is in Brooklyn, New York, though we also have an additional building in Manhattan. And as an art, design, and architecture school, Pratt recognizes the profound impact that designers and creative professionals have on shaping industries, influencing the built world, and reducing harmful impacts on health, justice, and the environment. At the heart of our efforts is providing students with the knowledge, tools, skills, values, and resources to address intersectional sustainability challenges during their studies and in their future careers. A key resource supporting this work is the Pratt Sustainability Center, which is where I am currently, which is an initiative that I've been involved with for the last 15 years and now lead. The center is an interdisciplinary research and resource hub dedicated to expanding sustainability in the academic experience of our students. We house a sustainable materials collection. We oversee various sustainability initiatives, coordinate events like Pratt Earth Action Week, which is our sustainability weeks, showcasing student and faculty work every fall and spring. And at the core of this work, and directly relevant to our discussion today of sustainable minds, is the fundamental question: what do we mean by sustainable? 15 years ago, when I first started this work at Pratt, I attended a final critique in a furniture design class where a student very proudly presented his final design, which was a chair, and he claimed that it was sustainable. So then I asked the question, and why is it sustainable? And he responded, oh, well, because it's made out of bamboo. And so I pressed further, asking why bamboo made it sustainable. And he had no answer. He couldn't really go into the details about what about bamboo sort of aligned with his sustainability goals. So this moment underscored a key challenge. It's not enough for students to recognize sustainable materials, but they need to understand why materials and design choices more broadly align with sustainability goals. Sustainable minds and life cycle thinking are tools that we use at Pratt to help students develop this critical thinking and critical understanding. Currently, several departments are using sustainable minds in their courses, some as our math and science course, ecology, environment, and the Anthropocene. It's just introduced in a single lecture to demonstrate the concept of life cycle analysis. And then in other courses, such as sustainability and production in our industrial design program, and life cycle assessment, which is the course that I teach in our sustainable environmental systems program, it's used throughout a semester-long project. And today I'm going to be sharing examples from both of those courses. The first example comes from a course that I teach in the Graduate Center for Planning and the Environment within the Sustainable Environmental Systems program. And this is all housed within the School of Architecture. This 2-year 40-credit master's program integrates environmental science, sustainable design, climate policy, et cetera, to prepare students for careers in environmental and sustainable design, sustainability, design, consulting, policy, analysis, and other related fields. My course is a 1-credit, 5-week intensive on life cycle assessment as a tool for environmental decision makers. Students learn LCA theory, structure, and application using sustainable minds to conduct a very simplified LCA. We work through the basic assessments. We emphasize the broader application, while we emphasize the broader application in LCA involved in more complex systems. For their projects, students select 2 everyday products that serve the same function but differ in design. For example, a single-use disposable paper coffee cup and a reusable coffee mug. They emphasize the materials, they analyze the materials, the processing, manufacturing, transportation, use, and end-of-life impacts for each of their products. And then using sustainable minds, they conduct a comparative LCA, making recommendations for improvement or redesign and assess whether their proposed changes actually improves the overall performance. The project for my class that I'd like to share with you is by a student named Hannah Whitney, who was in my class last semester in the fall. And Hannah compared a liquid shampoo in a plastic bottle to a solid shampoo bar in paperboard packaging. The first step was to analyze how each product was used, how much shampoo is required, how long a shower takes, how these factors differ between the 2 formulas. Students measured their own shampoo use, timed themselves taking showers to really ground their analysis in real data. They love this part of it. Next, the students examined the materials and components for each product, identifying the differences in their life cycle stages. Here we see the breakdown of materials for the shampoo bottle. And here is the solid bar. And then next, students conduct a qualitative analysis of each product's life cycle from raw material extraction through disposal. Beyond understanding the life cycle stages, they research the potential environmental and human health impacts associated with each life cycle stage. This provides critical context for the results that they will ultimately get when using sustainable minds, which otherwise appear as beautiful data visualization, but it doesn't necessarily clearly indicate which specific component or material or life cycle stage contributes to each impact category. So I emphasize with my students that sustainable minds is a tool, but not an answer. It helps quantify impacts, but students must critically evaluate the inputs and interpret the results beyond the software, beyond what the software presents. And here we see the same process, but applied, whoops, too jumpy. Here we see the same process, but applied to, there we go, the shampoo bar. After completing the qualitative research, students model their products in sustainable minds. The results here show the impact distribution by life cycle stage and material composition. One surprising, at least it was surprising to the student, finding in this case was the significant role that transportation had in the overall results. To refine their comparison, the students actually removed transportation from the analysis because it was sort of contributing such a large proportion of the impact, so that they could isolate the impacts related to packaging, materials, manufacturing, use, and delivery method. And this revealed that the choice of material and water use during showering were the primary drivers of impact. So by adjusting their recommendations and switching to a recycled plastic for the shampoo bottle, and across both cases, reducing the time that they were taking showers for, the students were able to demonstrate notable improvement in the sustainability performance. This underscores the critical insight that sustainability isn't just about materials or manufacturing processes, but it's also, and sometimes more importantly, about behavioral choices. The next example comes from our Sustainability and Production course, which is taught by Professor Frank Malero in our industrial design program. The course is required for all undergraduate students who are pursuing the bachelor's in industrial design, and it's a popular elective for our master's of industrial design students as well. And like my course, it emphasizes the designer's role in understanding environmental and social impacts, while introducing tools for assessing sustainability performance through life cycle assessment. The product structure is very similar to mine, but since this is a semester-long, traditional 15-week course, the students engage in a deeper exploration. One project that I wanted to highlight was conducted by another student named Hannah Wong Nakata, and it focused on Hot Wheels cars, which is a product that I know well as I have a 6-year-old boy. We have what feels like millions of these things. So students first analyzed the components and materials of the Hot Wheels car and its packaging. They then, Frank also requires his students to research the product's history, market position, user demographics, recognizing how the product is used, and the significant impacts that it might have on its sustainability performance. And so using sustainable minds, the student, they conducted the full analysis, but then they sort of drilled down into one specific design change, first relating to the plastic components, which were originally ABS, and then they proposed a change to PLA. And so the analysis here shows the impact reductions across most categories, which is what they were hoping for. But it also shows a burden shift. So you see eutrophication graph, the second one from the left, that the eutrophication impact actually went up because of the use of PLA. Beyond material changes, the student also explored usage scenarios. So they modeled different assumptions about playtime and how long a kid, or not just kids, it turns out, would actually hold on to these cars and use them. So they played around with doubling, tripling, quadrupling the assumed lifespan of the toy. And so you can see the graph here that shows that simply using the same product for longer dramatically improves its sustainability performance. And this reinforces, of course, the importance of product longevity and user behavior. Of course, there's challenges when using any sort of life cycle assessment tool. In my course, it's a 5-week course. And even in Frank's semester-long course, learning a new tool alongside other coursework can be overwhelming. Another limitation is the availability of materials in Sustainable Minds. Our students are often super excited to compare sort of new, innovative materials that aren't yet included in the database. So, but I've been using Sustainable Minds, Terry and I were talking, for probably close to 15 years now, and I'm always so pleased to see new materials that are added regularly. And then across these examples, we see how Sustainable Minds helps students challenge assumptions about sustainability. I always ask the question at the beginning of my class, sort of what aspect or what area of the life cycle they expect to see the most impact. And many initially believe that it's going to be the end of life, because that's what we see as consumers. We see the amount of waste that we're generating. And of course, by the end of the course, they're often surprised to learn that the materials, manufacturing, transport, and use tend to drive the majority of impacts. Students also develop a systems approach to sustainability, considering not just the materials, but use patterns, consumer behaviors, and how that might impact sort of the overall performance and trade-offs. They gain hands-on experience with life cycle assessment while improving their understanding of materials and manufacturing processes. Especially in my course, most of our students are not coming from design backgrounds. So, exploring what are these materials and how do they come to be is very illuminating for them. And that's it. So thank you so much.
Thank you, Carolyn. Amazing work your students are doing, and kudos to you and Frank for continuing that work and really producing a large number of knowledge workers for the Greener Product Marketplace. Now I'm going to pass it along to Gary, who is really going to tell you some very different kinds of product stories, and what he's been having his students do in his course year after year is nothing short of amazing. Gary, I'm going to turn it over to you.
Thanks, Terry and Holly and Carolyn. Great job. Gary Gruen. I teach in the Pratt School of Engineering at Duke University in the Management of Engineering, the Masters of Engineering Management program, excuse me. And my experience has been vast. I have 4 degrees. The latest one is a PhD in chemical engineering. I also have a mechanical engineering and chemistry undergraduate background and a master's in chemistry. Been involved, also have I'm a registered patent agent, so involved with the intellectual property, and been teaching in the engineering school at Duke on and off since 1992. I have been involved in green sustainable products and green energy and that type of thing for over 30 years now. I also have a small personal care company and a biofuels company that was both startups, unfortunately still in the startup stage. So as I mentioned, our course is on sustainability, and the title of it is Sustainable Products Using Clean Energy Transitions. My goal is to teach the students the following. We say, if it's not profitable, it's not sustainable. So the students are provided an understanding for both life cycle assessment and activity-based costing or costing techniques to value the products or processes or services that are being used. The engineering school has this 1-year program, which has now been extended almost to 2 years, sort of an alternative to an MBA. And there's a very big push in the school and in the university to make sure that they're learning marketable skills for jobs when they get out. So we've considered both the practical product and market factors involving everything from energy security and infrastructure to natural resources, climate regulation, and of course, profitability. Let's see. So the project teams are broken up. We have usually about 35 to 45 students in each class, and each life cycle assessment team is broken up based on products or processes or services that the students get to pick from a large group of mentors, and each one of the 4 to 6 member teams have a mentor for the project or the product that they're working on. During the semester, it's a 16-week semester course, 16-week long semester course. So these are the project logistics and goals. As you can see, they start with a base case or reference case and a comparative case. So that's where some of the intellectual property works comes in, and they determine on the base case, which is an existing technology or existing product, basically how to improve that product or technology. And they are expected to look at the life cycle assessment aspects of it, as well as the costs. And then they get into the knowledge after cost is, well, what do they do with that? Can they understand the market? They do a market analysis, and they eventually wind up with pricing so they can determine whether it's profitable. Because again, if it's not profitable, we say it's not sustainable. So I'm going to go through two case studies, and the case studies, one of them is actually for a biofuel company that was started by myself and 2 other individuals, one of whom was a class student and one of whom is a registered patent attorney. We came up with something called PowerShot, which is a combination of a waste byproduct of glycerin and isobutylene. Glycerin is a waste byproduct from biodiesel processes, and isobutylene is a waste byproduct from petroleum refinery. And we decided for this course, for this student group, this is only one of probably 30 student groups we've had so far. They were looking at the option between using this true fuel product, which is sold pretty much everywhere. It's a lubricant and advanced stabilizer that provides protection to 2-cycle engines like lawnmowers and leaf blowers, that kind of thing. And the environmentally friendly, quote unquote, octane booster using glycerol terbutyl ether, which is an alternative to MTBE, which is methyl terbutyl ether, which we know is has been outlawed throughout the United States by the EPA. And that's why you're using, instead of leaded gasoline with MTBE, right now you're going to the pump and you're buying gasoline with ethanol. So everybody who's watching this is, in the United States anyway, is buying E10, which is 10% ethanol, not real gasoline anymore. So the difference between the two, from an environmental standpoint, of course, we're looking at all the different aspects from soup to nuts, the entire supply chain. Students have to look at that so that they can do a proper limited life cycle assessment, which is what I call it, because it's geographically dependent. As the 2 earlier speakers mentioned, we found that energy and transportation are always the key factors. And so when you compare these 2 products, the question is, how much different are they? Not only materials wise and how they're processed or made, but how much differently they have to be handled and how they have to be made and where they're going to be distributed. So what they did is they used Sustainable Minds, among other life cycle assessment tools that we have available. And this is the results, as you can see, comparing the Tri-Fuels product to the PowerShot product. And you can see that there's quite a difference in terms of the emphasis in one area or the other as to where the, let's say, lower environmental and health impacts occur. And we found, or the students were able to find, that it might be sustainable. They're looking at the fact that certainly the CPS PowerShot product has a lower overall environmental impact. However, when they looked at the next part of this, they were able to see that by doing costing analysis and a manufacturing analysis, and they just determined that the levelized cost for making the Tri-Fuels product was a little bit higher than the making of the CPS product. However, they also realized that this manufacturing process is going to lead to something which they weren't necessarily familiar with, that, take a second here, which is toll manufacturing. And I guess I skipped through the second slide, but the result of it was they felt that toll manufacturing, by having a third-party manufacture the product, that the PowerShot product, which is the glycerol terbutyl ether together with the isobutylene, was a possible profitability. And that's how they were going to manufacture and distribute the product and compete. The second case study I wanted to mention is for a company called Go Wheels. The mentor, who also lives close by in the Durham Chapel Hill community, decided that he wanted to do something about shopping carts. If you've ever gone into the stores with the shopping carts, you always seem to get one with wheels that don't work too well. This one, this gentleman, an inventor, also patented inventions. In fact, all the stuff we use has usually got patents and trademarks associated with it for the class. And he basically decided to reinvent the wheel. And you can see the traditional wheels that you'll see on shopping carts in grocery stores, and they're even used in industrial environments for baskets that are moving along the way. And you can see that these wheels are throwaway wheels. And what he did is develop a retread item so that you can actually take part of the wheel apart and retread it. And these are how they manufacture the products. They're still using the same basic materials. However, at the end of life, you can recycle the tread, as you see on the right-hand side. So this were comparison cases to show the difference in the functional units and how they performed based on a life cycle assessment using SM, Sustainable Minds. And you can see that they found that the performance with the comparison case was substantially better. And of course, they did an overall LCA and found that the impact, or the carbon dioxide footprint, if you will, was quite different from the actual base case, which is, and the comparative case, which is the recycled wheel or the recycled retread. So they dove a little deeper, and they found that there were other impacts as well. And they found that, again, that the energy being used to manufacture this was important. The geographical location was important. And all of that was conducted by the same group of students. And you can see that their overall cost analysis showed that the savings per replacement per wheel, quite substantial, and savings in waste to landfill substantial, savings in manufacturing substantial. And they combined that reduction in the environmental impact, which was almost 2 million pounds. Of course, this is based on a global analysis. The company actually is already have their products in Food Line. They've just signed an agreement with a second large chain, to actually make an impact. And one of the students is actually working with these folks. I know I'm up with my time. Many of the Duke MEMP students have been using this technique to actually add to their CVs. They all want good CVs. They want to have a good impact when they get out. And the fact that they've been using Sustainable Minds, life cycle assessment, and activity-based costing as a decision tool has helped them with their interview process. So that's our education. That's how many people across the departments are making decisions using LCA and life cycle assessment and activity-based costing. We like to integrate that into an early stage design. And then at that point, I know we only have a few minutes left, and I'll throw it back over to Terry so you can ask some questions.
Thank you, Gary. I think what you've put together and the way you run your course is really powerful, and clearly you're getting, amazing results from your students. I do want to make a finer point on something you brought up, and for the benefit of some of the folks attending, that you make several LCA tools available to your students to use in the process. And people say, well, can we use, why shouldn't we be using CIMA-Pro or Gabby? Why should we use, Sustainable Minds streamlined LCA tool? And the answer is that you want to use the right tool for any job, no matter what the job is. And so a streamlined LCA tool like Sustainable Minds is created and useful when you're in early stage product development and concept creation where you can rapidly make comparisons, because by definition, product concepts are loosely defined and rapidly changing. Whereas Gabby and CIMAPRO, the professional tools, are very explicit and they're very technical. You need a fair amount of technical knowledge to use them, but you really use them when you want to solve a different problem, which is to go deep on where are the impacts actually happening, get very explicit results, model in more detail. And oftentimes organizations will have their product teams using Sustainable Minds early on in product development, just like all of these educators have shown. And then what it will do is it will narrow down the range of possibilities of how to change a product. And then they may go do a more explicit LCA model, but they've saved months of time by narrowing the investigation early on to get to a smaller set of options to then go and prove out. So I'm going to thank all of you who have attended today, and I want to thank all of our educators, Holly, Carolyn, and Gary, for being so generous with sharing your stories and your time. As you guys leave, please take a minute to respond to our survey, and we are finishing right on time. So I'm going to say have a great day. Thank you, Holly, Carolyn, and Gary, and we'll be in touch.